Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Karamil bin Muhammad Noor. Today I'm going to introduce about my project that I've been developed during my deep learning in intelligent video analytics and computer vision workshop in IIUM called the Sign Language Translator Alphabet Version using Jetson Nano. So this project is about translating sign language alphabet using Jetson Nano, and it focuses on the image classification where every hand posture will be classified to its own letter class. So this is the proposed system where all the obtained dataset will be fed into the classification system, and the system will classify them into their own letter class. The methodology and implementation of this project is where firstly is the dataset, where all datasets are obtained from Kaggle and cell captured. These datasets are provided using the link in the description below. Next is the pre-processing. First, all the images from test and validation file will undergo several image transformations such as resize, blurring, cropping, and also normalize. Next is the training. So the training is using the ResNet 18 pre-trained model with extra fine-tuning. So the problem with this project is of course the almost identical hand posture where such as letter E is almost identical to the letter S and also almost identical to the letter M. So let's get started. So below I have provided the my GitHub link about my project called the Sign Language Translator using Jetson Nano over here. Firstly, you can just clone this repository over here in your command prompt, and you will get the project ASL IPNB, and then you will get the image.py. So what is important here is the project ASL IPYNB. So this is the project ASL IPYNB open in Jupyter Notebook. If you don't have a Jupyter Notebook, you can create one. You can install Anaconda and Conda install notebook, and also you need some few library over here. The most important one is the Torch and Torch Vision, and also some few library as you can see over here. So this project IPYNB is provided in my GitHub link, so don't worry about it. So first of all, as I just mentioned about earlier, so all the images from the dataset will be transformed. As you can see here, resize will be also this will be Gaussian blur, rotate, and much more. You can see, and then you need to specify the dataset path after you downloaded the dataset. And also this is the training. This is a training model using the ResNet 18, and this is the fine-tuning you can see over here. So this is the epoch I've been run before but got interrupt. So more epoch may produce a better accuracy, as you can see here. So if I run until 100, it can make until 90% and more. And then this is the plot, and then plot diagram, and this is to find the accuracy, and this is decoding to find the confusion matrix. The important thing is after completing all training, this is the important cell you need to run because it will save the project into the name of best model pth.tar, which is important to be used by the Jetson Nano. You can run this Jupyter on your PC, or you can also run on your Jetson Nano, but for better performance and faster training, you can run it on your PC and then save this file and transfer it into your Jetson Nano. So the next step is to run it on Jetson Nano. So first of all, you need to git clone this repository in your terminal. This is the repository created by Dusty Franklin, one of the NVIDIA developer that I've used during my workshop. And then a folder called Jetson Inference will be created, and inside this folder you need to go to Python example, and you will see one imagenet.py file, and you need to copy this and put it inside Jetson Inference, Python, training, classification, and you need to paste it in this folder, as you can see over here. Next, in this folder, there will be one folder called the models. So inside that folder, you need to create one folder called anything you want, or in my case, I put project. And then you need to place your save pth.tar file you just did just now inside this project, or also I provided in the link below. See here, you can paste it inside this folder. Mine is gone because I have already exported into ONX file. You can see over here. This ONX file also provided in the drive link, and then you can just paste inside this project folder for your own usage. And then you need to copy an ASL text provided in the drive also. You can download it and paste it into the data folder inside classification, inside another folder you've created called project, and you need to paste it inside the folder, or you can also run it on terminal, and then you can put gedit, and then in this text file you can just put all the class name, which are the class A, class B, C, and until Z. Alright, I already did this, so I don't need to save it again. And then close the terminal, and we have this asl.text file inside the project in classification data project file. And then this is to test the project on Jetson Nano. So firstly, you need to open your terminal, and then you need to change directory to Jetson Inference, and then Python. Python, and then training, then classification, and you can copy this code over here. You can just copy the code over here and paste it on the terminal, and then as you can see, this is how it's implemented. So as you can see, go into training, classification, and you need to have the image.py, as you can see over here. And then for models project ResNet ONX is this one. This is the important part. And then the input blob equals to input 0, output blob equals to output 0, and the labels. This is the second important part, which is this, the data project ASL text, because it needs the class name for it to work. So now you can run it on your video device, and it will take a moment. Alright, so there you go. This is the window pop out. So now you can use your sign language on the camera, and it will be translated into its letter, as you can see on the upper left hand side of the window. So this is V, letter V, this is letter W, it's supposed to be K, wait, yeah, alright, this is K, and this is supposed to be F, yeah, there you go, you can see F a moment, just now, a glimpse of F over there, okay, and this is letter Y, so that's all from my project. Thank you. Kau dah tunjuk kat sini dah. Jangan lah.
Yes.
B,
C. It's supposed to be C. E double K.